Alright, so here we are with lecture 1.3. So we're taking a look at algebraic expressions. So what are algebraic expressions? Well, it's an expression that is built of integer constants. Okay, so in an integer constant would be like 1, 2, 3, 4. Variables, okay, so like x, y, z, and algebraic operations. Algebraic, ooh, not the best handwriting there. Algebraic operations. Okay, so for polynomials, the leading coefficient we would call a sub n, and the constant term would be a sub 0. Alright, so example 1. Classify the polynomial, identify the terms, and state the degree. Alright, so this here is a polynomial. So real quick, poly means many, right? So many and nomial would be terms. So polynomial is talking about anything that, let's say if we had 2x, 3x, any of these algebraic terms with as many terms as you want. So we could have 1, 2, 3 terms, or we could have 1 term, or we could have 1, 2 terms. Okay, so how do we figure out how many terms we have? Well, what I like to do is I like to look at things separated by the plus or minus signs, and that gives me a hint at how many terms we have. So we have 2 plus signs here, which means we have 1, 2, 3 terms. So this is a 3-term polynomial. And 3-term polynomials, they're lucky, they have a name. They're called a trinomial. Like a tricycle, 3-wheeled thing. A trinomial is if we have 3 terms. Okay, so we classified the polynomial to trinomial. We identified the number of terms, 3. And I needed to state the degree. So the degree, we're going to look at the variable and try to find the highest exponent. This one doesn't have a variable. This one does. That's x to the 4th power. But this term has x to the 5th power. So this one wins. So this is going to be a degree 5 polynomial. Okay. So B. How many terms does this have? Well, just 1 term. So it's a 1 term. 1 term. What would we call this? Well, this would be a monomial. Mono meaning 1. So monomial. 1 term. And what's the degree for this polynomial? Well, what's the degree for my x? Remember, it's that hidden 1 hanging out up there? So it's a degree 1 polynomial. All right, one more example to go. Go ahead and try to see if you can find out how many terms there are. Okay, let's see. Here's the plus sign. And I have 1, 2 terms. So it's 2 terms. And this one has another name. It's called a binomial. Think of a bicycle, 2-wheeled. Binomial. Okay, and then what would the degree be? Let's see. The 3 doesn't have a variable, but the 4 does. And the degree on the 4 is a 3, so it's a degree 3. Sorry about the bug. Okay. All right, so you might wonder, what if we have 4 terms or more? Well, pretty much anything past 4 terms, we would just say a 4-term polynomial. They don't really have special names. It's these 3 that have the special names. So binomials, monomials, and trinomials, those get the special names. All right, so here we go. Let's take a look at adding and subtracting polynomials. Okay, so let's see. We have this polynomial, and we're subtracting from it that one. So I'm going to go ahead and distribute that negative sign to get rid of the parentheses. So let me first rewrite the top terms. So x to the 4th minus 3x squared plus 5. And now we're distributing. So a negative times x cubed is going to be negative x cubed. Now distribute the negative to the negative 4x. Negative times negative, positive 4x squared, excuse me. And then let's distribute that one last time to the 7. So that's going to be negative 7. All right, so now what we're going to do, after we've distributed, we're going to combine like terms. Let's see. X to the 4th. Any other x to the 4ths around? Nope, that's the only x to the 4th term. Now let's take a look. X squareds. Are there any other x squareds around? Ah, right there. So, negative 3x squared plus 4x squared is going to be plus x squared. You could write the 1. Most of us don't write the 1x squared, though. We'll just leave it as x squared. Okay, so we looked at those ones. Let's see. Do we have a constant term? Oh, we have another one right there. Negative 7. So 5 minus 7 is going to be negative 2. And we're done with those terms. And one term that we haven't looked at would be the negative x cubed, but that one doesn't have anybody else. So write negative x cubed. And lastly, we're going to kind of rewrite this. Normally, you write your answer in descending powers, which means the 4 would be first, but after the 4, we want to have the 3. So let's do that in descending powers. And then the squared will come next, and lastly, the 2 term. So now this is in descending powers. Okay. And box our answer. Nice and clean. All right, and notice I try to keep the equal signs lined up so you can follow my work as neatly as possible. All right. Example 3. Multiplying. Okay, so before, notice we did a subtraction for polynomials. Now we're moving to multiplying. Okay, so what we're going to do is use the distribution property as many times as necessary. So we have the first term here, which is a binomial, 2 terms. And the second one is a trinomial, 3 terms. So what we're going to do is multiply and distribute this to those 3 terms, and then we'll distribute the 1. So let's go ahead and distribute the 2. So that's going to be, let's see, 2x times 3x cubed is going to be 6x to the 4th power. And then distributing it to the 5, we're going to get plus 10x squared. And lastly, distributing it to the 7, we're going to get, oh, remember that's a negative 7. It's going to be negative 14x. All right, so now we've distributed the 2 to everybody. Next we're going to do, distribute the 1 to everybody. So 1 times 3x cubed. That's relatively easy. That's just multiplying everything by 1. Okay, go ahead and work with me on the distributing. So 1 times 5x is going to be 5x. And lastly, 1 times negative 7. Remember that negative. Okay, the negative is attached to the 7. We have to keep that when we're multiplying. So negative 7. All right. Ooh, these bugs are everywhere. Okay, so lastly, same thing. Let's combine like terms. All right. Do we have any x to the 4th powers anywhere? No. So let's rewrite 6x to the 4th and nobody to combine you with. How about x squareds? Any other x squareds? Nope, that's it. So we have plus 10x squared. And I'm just lightly crossing this out so I can keep track of which ones I've added. You don't need to cross them out if you can keep track without forgetting which ones you've added, but I find it's a nice, helpful way to not accidentally re-add numbers. All right, how about the x's? We do have like terms. Negative 14x and 5x. We can add that and get negative 9x. Okay, we're done with those. How about any 3 x cubed? Any other x cubes? No, just those two terms. So plus 3x cubed. Done with that. And lastly, we have our negative 7. There are no other constant terms, so we'll just write that down. Okay, and what are we missing? We want to write this in descending powers. Okay, go ahead, try to write that in descending powers. Okay, here we go. Check your answer with mine. Okay, once again, notice I try to make sure my equal signs are lined up so you can follow my work, and then I box my answer. Okay, one more page for this part. All right, here we go. We're doing special products. Okay, so we want to factor 10x cubed plus 5x completely. So when we factor, we take a look at the terms and try and figure out what they have in common. So 10x cubed plus 5x. Let's break that down a little bit. 10 can be rewritten as 2 times 5x cubed plus 5x. Notice both of these terms contain a 5, and they also contain an x. In fact, this one has a few extra x's. So we can go ahead and factor out what they have in common, which would be a 5x. So what's left over when we take that out? Well, for this term, what's left over is the 2, and we only took away one x, and this one had 3 x's, which means there are 2 x's left over. Okay, plus, now this term, we took out a 5x, so you might be tempted to write a 0 here, but remember, what's left over is a 1. Okay. So if you wanted to check your answer to make sure you factored it correctly, how could you do that? Well, you can multiply it back out and see if you get what you started with. Sorry, you might be able to hear the roosters crowing. They're waking up for some reason. Okay, so let's check. Multiply it out. 5x times 2x squared is going to be 10x cubed. And then 5x times 1 is going to be 5x. Is that what we started with? Yep, it is. Okay, so we factored correctly. So if you want to check your answer, you just go ahead and you use the distribution property and you can check to make sure you factored correctly. Okay, so since we factored correctly, let's go ahead and proudly box our answer. And there we go. All right, so let's take a look at example 5a. So this one, okay. Good thing to note, depending on the type of polynomial you're working with, you have different factoring methods. So this one is a 3 term. Okay, so we're just going to use the normal trinomial factoring method. So let's see. Since the x squared doesn't have a number in front of it, we know it's just going to factor as x. And now what we're looking for is factors that give us -3 when we multiply, and then when we add, give us a +2. So let's say factors of 3 are just going to be 3 and 1. Can I add 3 and 1? Or sorry, can I subtract? We're using subtraction symbol here. Let me highlight that. Can I subtract 3 and 1 to get 2? I can. If I do 3 minus 1, I'll get 2. Okay, so that means the 3 is the positive term, and then the 1's going to be the negative. How do I check that this is the right answer? Well, remember, we can use FOIL. Okay, so here's us checking. So the first term, x times x, is going to be x squared. So first and then outside, x times 3 plus 3x. Inside, minus x. And last, -1 times 3, -3. Adding that together, we have x squared. These are like terms, so that's going to be plus 2x. And then we're minus 3. So is that what I had in the beginning? Yes, it is. Okay, so my answer is correct. I will go ahead and box it. Okay, so let's take a look at B. Okay, so let's look at our terms. We have two terms, 1 and 2. Do they share anything in common? They do. It might be a little hard to see, but they both have the 3x plus 1 in common. This whole term here, this one has it twice, and this term has it once. So we're going to factor out the 3x plus 1. And what's left over? Well, this term had two 3x plus 1s, which means there's only one left over. All right, and then we're using the minus. That's the same minus here. Minus 4. And we take out this term, 3x plus 1, which means only the 4 is left. So we're done with that. Okay, so we always have to make sure that we can't simplify anything. 3x plus 1 we can't simplify. Those are all unlike terms, so we'll just rewrite that. But take a look inside this parentheses here. There are some like terms. We have that 1 and the negative 4. So real quick, I'll just drop the parentheses. And now you can see that the 1 and the negative 4 are like terms, so we need to combine those. And we're left with 3x minus 3. Okay, so if you're curious, you can go ahead and FOIL this out and check and make sure that we get something similar to this answer. Okay, it might look a little different though because we have this squared term here. But it might be fun to see if you can get the same answer when you check your work. All right, so we have special factoring formulas. Let's move on to special. All right. This one here, how many terms does it have? 1, 2. So it's a binomial, but there's a subtraction sign. Okay, that's interesting. And we have the x cubed and the y cubed. That brings back something that you've probably seen before. It's a special factoring formula, and we'll take a look at that in a second. But before we do that, notice the 16 and the 2. That is a like factor. So I'm going to go ahead and first factor out. What do they share in common? They share in common a 2. So let's factor out a 2, and what's left over? So 16 factoring out a 2 is going to be 8 left over. 8x cubed minus y cubed. All right, so this right here, that is a special factoring formula. Or sorry, special term that we're going to use the formula. I'll write it down for you. This is called the difference of cubes. Okay, why do we call it that? Well, we have the subtraction sign, hence difference. And we have x cubed and y cubed, hence the cubes. Okay, so the formula for this, if you see a value cubed minus another value cubed, we can factor this into a minus b times a squared plus ab plus b squared. Okay, that is the formula for difference of cubes. Let me go ahead and stick that sticky note up on the side here for reference. Okay, the only problem I have here though is I have this 8 here. That 8 is not being cubed, so I have to figure out how to rewrite this so I can factor correctly. Well, if I look at 8x cubed, that's the same as 8 is the same as 2 to the third power times x cubed. And using rules of exponents, I can back this up and write this as 2x cubed. That looks a little better. So let me rewrite this as 2 times 2x cubed. Ooh, where's my whiteout? A little messy there. Let's try again. 2x cubed, there we go, minus y cubed. Okay, so to use this formula, I want to identify what the a value is and what the b value is. Well, the a value is the first one cubed. So here's my a, 2x. It's my a value. And my b value is y. Ooh, that's supposed to be my b value. Huh. Okay, there we go. Let's go ahead and use the formula. So this is going to be 2. The 2 is just hanging along for the ride, so let's put that there. 2 times. Okay, we can factor this into our a value minus our b value. Well, my a value is 2x, so I'll write down 2x minus, and my b value is y. And then it says to take my a value and square it. Well, 2x was my a value, so I'll go ahead and square that. Then we're going to add to it my a value times my b value. My a value is 2x, and my b value is y. Then we're going to add to that our b squared. So plus my b value squared. So my b value was y. Alrighty. And there we go. We have used that formula. So let's go ahead and simplify this because that looks really ugly. So 2x minus y, simplifying. 2x squared. Well, using rules of exponents, we can distribute that in, so that's going to become 4x squared plus, multiplying this out, we'll get 2xy plus, and then we can simplify that to y squared. Okay, sort of encroached upon my other problem here. Okay. So that is it for this problem. That was kind of fun and sneaky. So first we had to factor out a common term there, the 2, and then we had to recognize that this was the difference of cubes. So the best way to recognize that is, one, just sort of always be on the lookout for the difference of cubes. Okay, so if you see a binomial, so 2 terms, and there's a subtraction sign, just try and check to see if this is a perfect